Hey, let me show you what happens when you run EEG data through a game engine built for 3D modeling and how you can do this yourselves. But first let me ask you, what type of data do you find more attractive? The MRI and PET data on the left or the MEG data on the right? I bet you'll go for the one on the left, right? Well, I happen to disagree. EEG, and in this case MEG data, shows brain activity. In other words, what the brain is doing, and isn't that what its core business is? Alright, but why does it have to look so boring then, I hear you ask? Well, agreed. Let's do something about it. If you think about it, EEG data could be so much more attractive. Think of MRI or PET visuals, but then dynamically changing over time, like a 3D movie of the brain. Yeah, but would that still be useful? I hear the scientist in you ask. Definitely. We often want to present data to colleagues, students or patients, so making it more intuitive than just a bunch of lines will already help tremendously. But then, for persons trying to learn visual EEG evaluation, it will also help when there is a more anatomical readout instead of just the raw signal. And finally, I don't know if you can see the animal in the lower right square, as its image is rather unstable, but by versatile ways of showing complex brain dynamics, we might discover new meaningful patterns, ones that we would not immediately stumble upon when doing quantitative analysis. The naked eye is a powerful observer, and it is for that reason that visual evaluation still plays a large role. Alright, enough reasons. I may have convinced you. How are we going to do this? Meet the game engine. My own computer game playing was mostly in the era when the main character was just a few pixels, but nowadays games are frighteningly realistic. Wouldn't it be great to be able to harness this kind of graphical power to visualize brain activity? Well, yeah, but programs like this are probably very expensive and complicated, and you need to have a team of dedicated programmers. Not at all. This top-level game engine is freely available on the internet, and you can start right away this afternoon. How does it work then? Well, think of a very elaborate version of PowerPoint, but in a 3D environment. You can make or import 3D objects and then change all of their properties like shape, size, movement, color, and so on. For instance, you can make a 3D brain, divide it in regions and give the regions different properties. And best of all, you can base their behavior on your EEG data. For this you do need some coding. Scripts like this one is written in C# can give the objects intelligent behavior, like changing their color or shape based on the incoming data. Fortunately, much of the scripts you need can be found online. Game engines are not primarily built for data visualization, so this needs some tweaking, but you will be rewarded with your data looking more sci-fi than ever. Let's give you an example and introduce Scatterbrain. This is a demo from software developed at the Amsterdam University Medical Center in Netherlands. Here you see a small segment of raw 21-channel EEG data being displayed in a transparent brain. This is real-time broadband data. A higher signal amplitude in a region is translated to a brighter light. What can we learn from this? Well, as dynamic brain data quickly becomes overwhelming, it is very important to be able to focus on specific regions, frequencies or measures. So the program can filter the data as we speak and regions of interest can be highlighted. We can also show more averaged activity over time to have a less dynamic but easier to read picture. The average data can be spectral power, functional connectivity or even more advanced network analysis measures. And we can also show live, rapidly changing communication patterns based on instantaneous coupling measures. And it doesn't stop there. Now I've shown you EEG and MEG examples, but you can make this work for fMRI, invasive EEG, corticography or even pathological spreading patterns as in neurodegenerative disease. So think of the next time you're presenting, studying or exploring neurophysiological data. We hope to have our program freely available online this year, but my real take-home message is, try this at home. There are no costs involved, except a fairly modern computer, but hey, you have that already. And okay, you do need some brain data, enough time and a lot of patience, but with that you can make your data look like a Hollywood movie and help us EEG scientists become the rock stars of the 21st century. Thank you.